Today we're going to be talking about ratios, rates, proportions, and percentages. So the first thing we need to do is make some definitions. The ratio, the definition of ratio is the quotient of two quantities that's with the same units. So the values have to be whole numbers as well. So for example, 1 to 2 is a ratio, or 1 to 2, written 1 over 2, or the ratio of 1 to 2 with a colon. These are all mean the same thing. This is the quotient of two quantities with the same units, so we're comparing two numbers. So a rate is similar. It's a quotient, again, of two measurements, but this time with different units. For example, 30 miles per hour is written as a rate would be 30 miles per 1 hour. So that's what 30 miles per hour means. Another rate would be $5.28 per every 2 gallons. Now, normally we don't do per 2 gallons. Often we talk about per 1 gallon. And if we're doing things per 1, for example, 30 miles per 1 hour, or how many dollars per 1 gallon, that's called a unit rate. A unit rate is a rate whose denominator is 1. So let's go back to this example, $5.28, and if we actually take that and divide it by 2, we get $2.64 per gallon. This is a unit rate, where the first one is just a rate. Okay, so let's do a couple examples with that. Let's say you earn $2,160 for 12 weeks of work. What is your weekly rate? And that's what we're talking about, a unit rate. So I'm going to take $2,160, make it a ratio with 12 weeks of work. If you take 1,260 and divide it by 12 in your calculator, you're going to get $180 per week. That is your weekly rate. Because we're talking about time is going to go on the bottom. Let's do another problem. Miguel drives 120 miles in 4 hours. How fast is he driving? We're talking again about a unit rate. So I'm going to take 120 miles divided by 4. Again, the time is going to go on the bottom. 4 hours goes on the bottom. When I divide this, I get 30 miles per hour. And that's the unit rate at how fast he is driving. Joshua works 8.5 hours for $95. Which one's going to go on the top? Well, 95 is going to go on the top because hours, 8.5, needs to go on the bottom because time goes on the bottom. So when I take 95 divided by 8.5, that gets me 11.176. Now we're going to round to the nearest cent, so this 6 tells that 7 to round up. So that's going to be $11.18. The 6 tells the 7 to move up to an 8, and that's per hour. Next, we're going to talk about proportions. A proportion is a statement that equates two ratios or rates. So for example, 1/3 is equal to 2/6. This is a fraction equals another fraction. Now, there's no x in here, so there's no solving to be done, but we will be solving pretty soon. This is just an example that 1/3 is the same thing as 2/6. They are equal, and this is a proportion because we're setting two fractions equal to each other. Two ratios, set them equal to each other, that's a proportion. The next one, 120 miles for every 2 hours, is the same thing as 60 miles for over 1 hour. So 60 miles per hour is the same as 120 miles per every 2 hours. This is two rates because they're different denominators. Different units, I'm sorry. So this is a proportion. So the next one, x over 4 equals 12 over 16. Even though x is a variable, this is still a proportion because it's two ratios set equal to each other. Or even if they're all variables, a over b equals c over d is also a proportion. Now we're going to learn how to solve proportions. When you're solving proportions, we're going to use something called cross multiply. So let's say you have a proportion A over B equals C over D. Then what we can do is we can cross multiply and take A times D and set that equal to B times C. So it's like you're multiplying across and then setting an equal to multiply across, kind of like you make a little butterfly there. I've on the image over here, I've put the arrows to show you that you're multiplying across and you're setting the things equal to each other. So let's do an example here. Let's say I have 2/3 is supposedly equal to 7/12. Now this is saying true or false. I'm not sure if it's true or false, so I guess I should probably put a question mark on the top because I don't really know. To check if it's true or not, I'm going to multiply 2 times 12, and that gets me 24, equals, and then I'm going to multiply 3 times 7 and get 21. Does 24 equal 21? No. So is this statement true or is this statement false? This is definitely a false statement because 21 does not equal 24. Let's try it again. We have 4/9 equals 12/27. I'm going to multiply across or cross multiply. 9 times 12, that's going to get me 108. Set that equal to, again, I'm not sure if this is true or not, 4 times 27 is also 108. So this does check. So is this true or false? This is a true statement because 108 does equal 108. So therefore, 4/9 does equal 12/27. So that's how you do a true-false problem. What if we have a variable and we're trying to solve for a variable? Let's do that, and we're still going to be using cross-multiply. So I have 3/4 equals x over 12. When I cross-multiply, I'm getting 4 times x. That's just 4x. Equals, and then I'm going to cross-multiply the other way. Notice it doesn't really matter which one you put first. It could have been 36 equals 4x or 4x equals 36. The commutative property says you can do either one. Now I have an equation that doesn't have any fractions in it. I much prefer to solve this equation than the one with fractions in it. So now I can divide both sides by 4, and that's going to get me x equals 36 divided by 4 is 9. So x equals 9 is my solution. I could check it if I want to. I don't have to, so I'm going to leave that to you if you want to check it. Let's do the next problem. 3/2 equals 24 over n. Again, we're solving for n. So when I cross multiply, 2 times 24 is 48 equals, I'm going to cross multiply the other way, 3 times n is 3n. Again, this is so much easier to solve than the one with fractions with the n in the denominator. That looks really, really hard. So in one step using cross multiply, I turned a hard problem into a much easier problem. Now I can divide both sides by 3, and I get n equals 16. On our next problem, we have 2x plus 1 over 15 equals 1/3. We're solving for x. So when I cross multiply, I'm taking 3 times 2x plus 1. Now 2x plus 1 needs to have parentheses around it because I'm multiplying 3 by the entire 2x plus 1, not just to the first term, but the whole term. Next, I take 15 times 1, and that gets me 15. So if you ever have a binomial in the top or the bottom, be sure that you put parentheses around it. 3 times 2 is 6x. 3 times 1 is 3. And now I have a much easier problem to solve. To get x all by itself, I'm first going to subtract 3 from both sides. That leaves me with 6x on the left and 12 on the right. Now I'm going to come in and divide both sides by 6, and my solution is x equals 12 divided by 6 is 2. Again, I can check that if I want, but it is an optional check, so I'm going to leave that check to you.